Hey guys, welcome back. Mr. Delora here, taking a look at another review of algebra from your previous year. Today we're specifically looking at formulas, perimeter, area, and one specific one called the Pythagorean theorem. Now, formula is simply a mathematical sentence in which we have one variable that's set equal to an algebraic expression. So a familiar one that we're going to talk about today is a perimeter formula. Perimeter for a rectangle is twice the width plus twice the length of that rectangle. Another familiar one that we will take a look at today is the area formula. Now, an area for a rectangle is base times the height. The area for a triangle is base times the height divided by 2. So those are some examples of some pretty common formulas that you may remember from last year. A perimeter is simply the length or the distance around the outside of a figure. It is measuring the length of the boundary of that figure. Whereas the area is the amount of two-dimensional space known as the square space that is inside the boundaries of that figure. So two-dimensional space or two-dimensional square space. I'm just going to draw a little square in there. Now the Pythagorean theorem is for right triangles. It says in a right triangle, I'm just going to give you a little triangle symbol there, the sum of the squares of the two legs is equal to the square of the hypotenuse. Now remember, in a right triangle, the two legs are the two sides of that right triangle that form the 90-degree angle. The hypotenuse is always opposite that right angle, and it's the longest side of that right triangle. And it simply says if I square both legs of that right triangle and add them together, we will get the length of the hypotenuse squared. Now, this is a pretty interesting formula. We're going to use it throughout the year, and we'll take a deeper look at it in coming months. Now, this formula also introduces squares, and we have to think about square roots. So squares and square roots are inverse operations of each other. Square simply means to multiply a number by itself. So here in the Pythagorean theorem, we are taking the leg represented by A and multiplying it by itself, the leg B multiplying it by itself. Then we're adding them together and setting it equal to the hypotenuse multiplied by itself. The square root is simply the means to find the number that is multiplied by itself that produces the number that you're taking the square root of. So let's get a little practice here. 9 squared is simply 9 times 9, and when we multiply 9 times itself, we get 81. Negative 4 squared. Now negative 4 is in parentheses. That means I'm going to take negative 4 and multiply by negative 4. So when I square a negative number, I'll see that I have a negative times a negative, which is going to result in a positive, in this case positive 16. The square root now of 49, I'm looking for the number that I would multiply by itself in order to get 49. And that number is going to be 7. Here we have 15 times the square root of 9. Now remember, before I do my multiplication, I have to do my grouping symbol of that square root. So the square root of 9 is 3. That becomes 15 times 3, which is 45. And next I have 4 to the 5 minus 2. Now 5 minus 2 is in parentheses and it's in my exponent. So I first need to do my parentheses first, that grouping symbol. 5 minus 2 is 4 to the third power, which really represents 4 times itself now 3 times. So this is cubing instead of squaring. 4 times 4, 16 times another 4 is going to result in 64. All right, let's get some practice with formulas now. It says in example 2, to use the formula for perimeter of a rectangle, which we talked about up top, perimeter is twice the width plus twice the length, to write an expression for the perimeter of each rectangle below. Now, it's important to note that we're just going to come up with an expression here. We're not actually going to have a solid value. It's just going to be an expression, which means it's going to have both numbers and variables left in it. So I'm going to start off by writing my perimeter, which would be twice the length, which is 2 times that 10x, plus 2 times the width, which is 2 times 6x. Now, as I multiply these through, I can multiply my numbers. 2 times 10 is going to give me 20x, plus 2 times 6, which gives me my 12x. And now I can combine these because these are like terms, and that's going to give me 32x. Now it's important to keep your units in there. This was in inches, and because I'm just measuring the length all the way around, these are just this one-dimensional measurement, so my resulting unit measure is just inches. Next, I'm going to do the same thing here for this other rectangle. I have a perimeter, which is going to be 2 times 4b. Whoops. Let's try that again. 4b plus 2 times 8a. All right, now as I multiply 2 times 4, I'm going to be left with 8b plus 2 times 8, which is 16a. And this is my final expression for my perimeter. I'm just going to add in my units of centimeters here because I cannot combine 8b and 16a. They're not like terms. They don't have the same variable to the same degree or exponent. Finally, let's take a look at using the Pythagorean theorem to find some missing sides of a right triangle. In our first triangle here in letter A, you'll note that I'm given the length of my two sides A and B. These are the two legs of the triangle because that forms the right angle. Let me just change colors here so you can see that. So this is my right angle here. And I'm going to set it up as the legs squared added together should equal to the hypotenuse squared. So that gives me 5 squared plus 12 squared is equal to my hypotenuse, which we're just going to leave as the variable c squared now. All right, moving to my calculator or doing my squaring in my head, because I know 5 times 5 is 25. Added to that 12 squared, which is 144, and that gives me c squared. Now I can add these two together. That gives me a total of 169. And that's equal to c squared. Now, I don't want to solve for c squared. I don't want the hypotenuse squared. I want to know what the hypotenuse is. So in order to undo a squaring operation, I need to take the square root of both sides, which is because squaring and square root are inverse operations. So my final hypotenuse length here is the square root of 169. We're going to punch that into our calculators, and we are going to get 13. Now, you'll notice that there's no units on this, so we could just leave it as 13 units, whatever the generic units are. All right, next up we have another right triangle. I have my two legs here, A and B. They form the right angle, but now notice that I don't have one of my legs. I instead have my hypotenuse. I'm going to set up my formula, my equation, my Pythagorean theorem, pretty much the same way, but now I'm going to say a squared, my leg squared, plus my other leg squared, which is 10 squared, should be equal to my hypotenuse, 16 squared. So now I have this equation here, and I want to get a by itself. So let's start by simplifying both sides here. We have a squared plus 100 is equal to 16 squared, which is 256. Now to isolate a, or to get it by itself, I'm going to subtract 100 from both sides. And that's going to give me a squared is equal to 156. Now we have the same problem that we did over here in our first example. We're going to take the square root of both sides to get the measurement of this leg A. So as I punch that into my calculator, I'm going to come up with the value for A to be 12.489. Now, typically in this class, we are going to round to the nearest tenth. So as I look across these last three digits here, I see that my hundredth spot is an 8, which means my tenth is going to round up to the next digit, which will be 12.5. And again, I have no units here, so I'll just leave it as a generic units.